Hello, I am Kholoud Althobaiti. I'll present our case study on understanding how an educational organization responds to reported phishing incidents. Most of us have received a phishing email similar to this, where the sender, who is the attacker, attempted to deceive us into clicking on links, as seen in this email, or giving away sensitive information. Organizations have a long-running battle against phishing. This is because phishing attacks can have a damaging impact on the targeted organizations, such as the loss of data, account or credential compromises, ransomware infection, other malware infection, and financial losses. So, when organizations measure the impact of phishing, they don't consider the monetary losses only, but also other critical factors. These include the downtime of the resources affected by either infection or loss of availability. The reputation damage. A simple example of this is when a phisher originates the phishing attack from a compromised account and sends phishing emails from a legitimate account under organizations. Another factor is the time spent on remediating the attack and mitigating its impact, and the financial losses that's spent on remediations and deceptive wire transfer. These financial losses can be expensive. For example, on average, the US organizations paid $1 million per incident just to remediate the impact of a long-running attack called Emotet that initiated from a simple phishing attack. This was between 2014 and 2020. In 2015, Google and Facebook wired more than $100 million to the scammer to pay for fake bills. And in 2019, organizations paid $28 billion to get their data back from the phishers who used phishing attacks to spread the Gantt crab ransomware. Many organizations take defensive measures to protect their members, clients, or customers from phishing attacks. This type of protection is split into 3 layers. In research, not all of these layers were explored. Prior research has focused on preventing phishing attacks, such as exploring best filtering methods and features, and applied them on the email services and personal machines. Prior research also focused on end users as the last layer of defense by training them to identify phishing emails and also report them to the IT teams of their organizations so they can protect other vulnerable users within that organization. Ideally, IT teams would use those reports to update the filters placed on the mail systems and repair damaged machines, so they mitigate the attack as fast as possible. Having a procedure in place to handle reported phishing emails is a recommended practice, but little is known about the practicalities and workflows used. So, the research question we are attempting to answer in this paper is, how does a large university in the UK handle phishing reporting and mitigation? As a first step, we started shadowing the help desk staff while they are doing their normal workflow and asked them follow-up questions. We started with the help desk since they are the first point of contact for anyone reporting a phishing message. The shadowing was about 1 to 2 days a week over 2 months. To get a bigger view of the workflow, we complemented the shadowing with analysis of the phishing reports handled by the help desk during 1 month of the shadowing time. We also ran feedback sessions with staff to ensure the correctness of the gathered information. We then conducted contextual interviews with other teams involved in handling phishing reports along with a number of the help desk staff. In total, we had 25 hours of interviews with 1 or 2 members of 6 teams involved. These teams ranged from network management, email management, and help desk. During the interviews, we asked them about the team rules in general and more specific questions on the phishing-based rules. We then showed them the diagram of the workflow and asked them to fill missing information. Our first finding is that handling reported phishing incidents require distributed cognition. The graph I showed earlier is simple compared to what we found. Phishing incidents are managed through several services that include the firewall, email servers, email exchange, and personal machine, each of which requires a specific type of expertise and unique system perspective. Thus, each of these resources are managed by a specialized team, along with other teams in charge of approving the process changes and setting up the guidance. Another finding is that we spot many of potential issues, many of which were linked to the simple fact that every report requires human processing. For example, the help desk staff process the user's reports, such as responding to their queries and identifying campaigns. However, taking into account that handling phishing is one task of the other many tasks the help desk are responsible for, this procedure is overwhelming, even with the considerable low number of reports we observed, which is less than 1% of the expected number if everyone reported the phishing emails they received. To reduce the load on the help desk staff, they triage the reports from one attack and only escalate a few of the reports to the other teams so they can apply their remediation. Although this shortcut is logical, it can be expensive as blocking emails is based on the content search. And since a phishing campaign is comprised of similar phishing emails with variations, blocking a campaign requires adding all the variations to efficiently remediate the attack. We also found that ticketing system and other tools such as the list of escalated emails to other teams contribute to the distributed cognition we already discussed. These artifacts facilitate the handoff between teams and help maintain situational awareness between them. However, they are error-prone because list and knowledge base are separated from the ticketing systems, and requires manual input, making it easier for staff to miss information. Our case study identified many opportunities for future research. There is a possibility to automate some of the human processing work observed in this case study in order to overcome some of the challenges found. One potential future work is to explore how to best employ machine learning techniques to automatically provide feedback to users that is customized to their queries. The ticketing tool's functionality could be adjusted to work with phishing reports, such as grouping reported emails from the same campaign, so to help teams better process phishing reports. Thank you for listening. Please read the paper for more information.